Hi everyone, Mr. Trophy here for our next lesson on linear inequalities. To get started, let's go over what a linear inequality is, which is an inequality that involves a linear function. And then we have a couple of examples of them for numbers 1 and 2. So let's see, if we have x minus 4 is greater than 5, well, if we want to compare x properly, we need to isolate it by itself, which will give us x is greater than 9 if we add 4 to both sides here. Then we can represent this on a number line just by plotting the value 9. And we're saying x can be anything greater than 9, but not 9 itself, since we just have a strictly greater than inequality sign here. So we can graph that with an open circle and an arrow to the right. Now we have a few more steps in this one if we want to isolate x. First, I think let's just subtract the 5x from both sides to give us 2x plus 12 is less than negative 10. Now if we subtract the 12 from both sides, we'll have 2x is less than negative 22. And to finally get x by itself, we'll get x is less than 11. So now let's graph this one as well on our number line, where we'll have 11, and we're saying it's less than 11 this time, so we'll go to the left, and 11 again is not included, so we'll leave that as an open circle. And I should be putting some arrows on my number line just to have good form with them. But from there, let's move on and try out a little more practice here with our next checkpoint question. So we have Lily needs to fill in the following statement with an inequality symbol. Negative 5x is blank in relationship to 35. And then we have the graph of the solution set for this statement is shown below. This graph, which is saying negative 7 and below, but negative 7 itself is not included. So now let's just go ahead with this inequality and practice solving it to see what we would have gotten originally with our statement. So we wanted to know if we divide by negative 5 here, we'll have x is blank in relationship to negative 7. But our solution says we have less than negative 7. Negative 7 itself is not included, so we're just going to leave that as strictly less than negative 7 here. And originally, since we had to divide by that negative 5, we knew we had to change the sign of this inequality once, so we started off with our negative 5x being greater than positive 35. But if we're comparing our solutions here off to the left-hand side with x at less than negative 7, well, if it's less than negative 7, it not necessarily will be less than negative 11. If we are less than negative 7, we have to be greater than negative 11. So B looks good. If we are less than negative 7, well, by default, we have to be less than negative 1 over 11, but we wouldn't be greater than negative 1 over 11. So let's go back and compare with letter choice B again. So if we have any x value less than negative 7, could potentially be bigger than negative 11, but it might not be. So if we had negative 100, for example, that's less than negative 7, but it is not bigger than negative 11. So B only works some of the times, whereas C, if we have something less than negative 7, we know it has to be less than negative 1 over 11 here. So C would be our best choice in this case. All right, let's try out another example here. This time, we're saying the length of Lisa's rectangular dining room is 12 feet. If the area of her room is at least 96 square feet, what is the smallest width the room could have? Why don't you see if you can set up an inequality which represents this problem, and once you do, we'll try and see if we can go over and solving it together. So go ahead and try and set that inequality up on your own now, and then we'll go and solve it together. Alright, for our initial setup here, we know we have some rectangular dining room that's 12 feet long, and it is some unknown width, which we can call x. And then we're saying the area of that dining room, which would just be length times width, or 12 times x, is at least 96 square feet. So we're saying it could be 96 feet, it could be more than 96 square feet, but we want to represent this with a greater than or equal to sign, just so we're making sure we include that 96. So now to solve for x here, we're just dividing by 12, and we're getting x is greater than or equal to 8. So the smallest width the room could have would be 8 feet. That's the absolute least amount x is allowed to be that would satisfy our area requirements here. For number 4, we're considering Rob makes $3.50 an hour working at a convenience store. If he gets a bonus of $25 this week, how many hours must he work to make at least 165? So clearly he's getting underpaid here, but let's see how much he would need to work if he wanted to earn that $165. So we know every hour he's earning $3.50 per unknown number of hours, but regardless, he's getting a $25 bonus here, so we can add that in. And we want to make sure this total adds up to at least 165. So we can include 165, but preferably we want more than that. So we're going to have a greater than or equal to sign again here. Now to solve for x, we can subtract 25 from both sides and get our 3.5x is greater than or equal to 140. Now if we divide both ends by our 3.5 to solve for x, we'll end up with x is greater than or equal to 40, which means that he could work 40 or more hours to earn his minimum of $165. For our next problem here, try and work this one out on your own. I think we'd need to compare two different statements to one another in order to solve for an unknown x variable. So why don't you go ahead and see if you can compare the inequality that we need to set up, and go ahead and solve for x then, and see if we can find out what our unknown number would be to satisfy this statement. Alright, so looking at this statement, we have 4x and 2x is less than the difference of 5x and 13. So we know we want to take the sum of our 4x and our 2x, and we're saying this is less than, has to be less than, the difference of 5x and 13. Well, if we take 5x and subtract 13, that will be their difference. So now to solve for x, I'm going to combine our terms on the left-hand side, and then I will subtract my 5x from both sides. So I get x is less than negative 13. So as long as we have some number less than negative 13, this statement will work out such that it will be true. Now let's try number 4, where we are asked to solve and graph this inequality. So I'm just going to recopy it down here so we have some more room to work with. Now, if we want to solve for x, I think the easiest thing to do here would be to multiply both sides of our inequality by negative 2, actually. That way we can get rid of this negative 2 in our denominator, which would leave us with 8 minus 6 minus 4x is less than or equal to, we've got to flip the signs here since we're multiplying by a negative number, then we get negative 18 on that right-hand side. So now, let's combine our like x's here, and we'll have 4x minus 6 is less than or equal to negative 18, and we can add our 6 to both sides, which will allow us to then solve for x by dividing by 4, and give us x is less than or equal to negative 3. Now let's go ahead and graph our solution. So on our number line here, we're going to plot negative 3, and we're saying x can equal negative 3, or it could be less than number 3, so less than or equal to. We're going to shade to the left there, making sure we have that closed circle for our graph. Now let's remind ourselves of one more vocab term before we continue. So we have compound inequalities, which are two inequalities joined by the words and or the word or. And here's an example of one joined with the word or. So let's go ahead and solve for m here so we can graphically represent this compound inequality. So on the left-hand inequality, I'm going to add 2 to both sides. Gives us m is less than or equal to negative 6. On the right-hand side, I'm going to multiply both ends by 8 to get rid of that denominator. That will give us m is greater than 8. So now if we want to see what values fit in for our compound inequality here, let's plot negative 6 and 8. We could have m is less than or equal to negative 6, or we could have m is greater than 8. which should look like this for our number line graph here. Now let's try out an example where we have a compound inequality joined with an AND statement. So we've got our two inequalities again. We want to solve for x. On the left-hand side, I'm going to subtract 8 from both ends of our inequality. And on the right-hand side, I'm going to multiply both of these by 7 this time to get rid of that denominator. So that goes x is greater than or equal to 1, and x is less than or equal to 1. So now, if we, or that should be less than or equal to 7. So now, if we want to go ahead and graph this, let's plot our 2 points again, our 1 and our 7. So we want the points where 1 is included, and we're looking at the area greater than 1. Then with 7 is included, and we want the spot less than 7. And we want the spot where x is both of these at the same time, since we have that and. So we're going everywhere in between our 1 and 7 here to give us our final solution set.